right, today we're going to be solving three variable systems. We're going to start by doing a word problem here so that we can formulate a three variable system of equations. It says, as a fundraising event, your club sold tickets to a special viewing of a new summer movie. The fundraiser was successful. You sold all 800 seats in the school's auditorium. You sold tickets at three different prices, $2.50 for children under 12 years old, $3.50 for youth between 12 and 18 years old, and $5 for adults. The total amount of money taken in was $2,937.50, and there were 4 times as many youth tickets as children's tickets sold. How many of each type of ticket were sold? The first thing we need to do is formulate the system of three linear equations in three variables to represent the situation. And then it says be sure to define your variables. That's something students don't like to do, but it's really important. At the end, when you've solved, it helps you determine what the answer means. It also allows you to read back the equations to yourself, make sure you set them up correctly. All right, so our variables come from what the unknown is in the problem. Usually comes from this last question. How many of each type of ticket were sold? That's our unknown, how many of each type. So we're going to make C our children tickets. Y will be our youth tickets. And A will be our adult tickets. Now that we have our three variables, we're ready to set up our three equations. When you have two variables, you need two equations. When you have three variables, you need three equations, and so on. The first one's going to come from right here where it said you sold all 800 seats in the school's auditorium. That means my children's tickets plus my youth tickets plus my adult tickets have to be equal to 800. The next one's going to come from the value. I'm going to multiply $2.50 times each child ticket plus $3.50 times each youth ticket plus $5 times each adult ticket to get a total of $2,937.50. Our last one's going to come from here where it says there were 4 times as many youth tickets as children's tickets sold. A lot of students see this and say 4 times Y because they see this part here. But if you read what the sentence is saying, it says 4 times as many youth tickets as children's tickets were sold. So they sold more youth tickets. So our youth has to be equal to 4 times our child tickets. In this case, 4 times C is going to give us that bigger number as Y. All right, we've got our three equations. We're ready to start solving. It tells us that you can solve systems of three linear equations and three variables by using substitution. So the methods are the same as the two variables, substitution and elimination. We're going to focus on substitution today. First, solve one equation for a variable and then substitute that expression into the other two equations. This reduces the system of three equations and three variables to a system of two equations and two variables, which you can then solve using any method. All right, it tells us here the equation, and the book has used T, but we used Y for youth, so go ahead and change that T for Y in both spots there. So the equation Y equals 4C is already solved for a variable. Substitute 4C for Y in the other two equations to create a system of two equations. So since we know that Y and 4C are exactly the same thing, because that's what this equal means, we can replace the Y with 4C in the other two equations, and then it allows us to have a two variable system. So we're going to go ahead and do that. I get C plus 4C, so I've replaced that Y with 4C. A lot of students, when they're doing that, they put the 4C and then they also put the Y, but then you haven't replaced it. So that messes things up. You want to replace the Y with 4C and only the Y. We can combine our like terms now when we get 5C plus A is equal to 800. We're going to do the same thing for the next one. We have 2.5C plus 3.5. Here's where the Y was, so we're going to go ahead and replace that Y with 4C plus 5A is equal to 2937.50. Again, we want to combine our like terms. So we've got a 2.5C plus 3.5 times 4C. That gives us 16.5C plus 5A is equal to 2937.50. we have gotten rid of the y with both of those. So I'm going to go ahead and rewrite them here so you can see we now have a 2-variable system. At this point, you pick whichever method you want to solve. You can go ahead and use substitution again. We can solve for a here, subtract that 5c to get it to the other side, and then substitute 800 minus the 5c in the place of the a right there. Or we can go ahead and use elimination. I'm going to go ahead and do that one. I want to get rid of our a's here since this has a coefficient of 1. So I'm going to multiply this top times negative 5. That's going to go ahead and give me a negative 5a, and those will cancel. So I multiply the whole equation. That gives me negative 25c minus 5a is equal to negative 4,000. The other equation just comes over. We don't have to change it. And now we're ready to add the two equations together. So negative 5a plus 5a is 0. That goes away. That's what we wanted. Negative 25 and 16.5c give me a negative 8.5c. And negative 4,000 and 2937.50 gives me a negative 1062.5. My last step is to divide by negative 8.5. So C is equal to 125. Now we've got the number of children tickets. We don't stop there. We need to determine still what our other two variables are. So at this point, I'm going to go back and place that in the place of the C right here. That would be the easiest one to get next, our Y value. So we get Y is equal to 4 times 125. So Y is 500. Now we've got two variables. We need to go back and get that last one. I could go ahead and plug it into that first equation. So we get 125 plus 500 plus A is equal to 800. We combine our like terms and we get 625 plus A is equal to 800. We subtract the 625 and we get 175. Now we have all three variables. So I know that we sold 125 child tickets, 500 youth tickets, and 175 adult tickets since we defined our variables. All right, we're going to do another word problem here. It says, during the movie fundraising event, the concession stand at the auditorium sells popcorn, fruit, and drinks. The price of box of popcorn is 50 cents more than the price of a piece of fruit. And the price of 2 drinks is 50 cents less than the price of 3 pieces of fruit. You order 2 boxes of popcorn, 1 piece of fruit, and 3 drinks. And the total comes to $7.75. Formulate a system of 3 linear equations and 3 variables to represent the situation, and be sure to define your variables. So again, we want to make sure that we define our variables. The 3 things we're looking for in this problem situation is the price of the popcorn, the price of the fruit, and the price of the drink. So P will be my price of popcorn. I'll go ahead and make F the price of the fruit, and D the price of the drinks. All right, so now we're ready to come up with our 3 equations. Remember, if you have 3 variables, you need 3 equations. The first one's going to come from the price of a box of popcorn is 50 cents more than the price of a fruit. Is usually stands for equal sign. So here our popcorn is, so P is equal to 50 cents more than the price of the fruit. So the price of our fruit plus 50 cents. 50 cents more than fruit is equal to popcorn price. That works. The next one comes from the price of 2 drinks is, so 2 times the price of our drinks equals 50 cents less than the price of 3 pieces of fruit. So 3 times the price of fruit minus 50 cents. That's 50 cents less than 3 times the price of fruit is equal to 2 times the drink. That matches our sentence. You ordered 2 boxes of popcorn, 1 piece of fruit, and 3 drinks, and the total comes out to $7.75. So 2 boxes of popcorn would be 2 times the price of popcorn plus the price of fruit plus 3 times the price of the drinks equals $7.75, which is what that last sentence says, so we're ready to go. In this case, the P is already solved for, so that's really good for substitution. It's ready. And this one's almost ready, so I'm going to go ahead and solve this one for D as well. I divide by 2. I'm going to go ahead and change it to decimals just to make it a little bit easier to work with when we put it into the equation. All right, so we know that P is the same thing as F plus 0.5, and D is the same thing as 1.5 F minus 0.25. So since we know what P is and we know what D is, and they're both in terms of F, we can actually plug both of those into here and make a one variable equation. So that's what I'm going to do next. So we get 2 times our P, which we know is F plus 0.5. Again, that P goes away because we have replaced it. Then plus F, which we still don't know, plus 3 times my D. And the D is right here, so we're going to do 1.5 F minus 0.25. Again, I've replaced the D with this, so it is gone, is equal to 7.75. We just took that from a 3 variable to a 1 variable by substituting both of those because they were both in terms of F, so we got lucky there. We distribute. So we distributed the 2 across this parentheses and the 3 across this one. Now we've got a lot of like terms there, so we need to put those together. 2F plus F plus 4.5F gives us a 7.5F. And then we've got a 1 and a negative 0.75, so that gives us 0.25. We're solving for that F, so we want to subtract 0.25. That gives us 7.5 F is equal to 7.5. So F is 1. We figured out the fruit is $1. Once we have one of them, remember you can go back and plug them in to get the others. In fact, you have to do that. So I'm going to take that F of 1 and I'm going to plug it in right here to get that P value, which is the price of the popcorn. So P is equal to 1 plus 0.5. So our popcorn is $1.50. And then we're going to plug it in right here for the F so that we can get the price of the drink. See that? 1.5 times 1 minus 0.25. So that's 1.5 minus 0.25, which is 1.25. Now that we've ended this problem, we know that our fruit is $1, our popcorn is $1.50, and our drink is $1.25. By defining those variables, I just made it much easier to realize what was the prices of each at the end, which is what we were looking for. We're going to do one last one, and this one's not going to be a word problem. It's just going to be a 3-variable system given to you. And again, we'll focus on substitution with this one. With substitution, you need a variable by itself. In this case, none of these are solved for a variable, so we're going to have to do that first. I would want to solve for the z in either one of these equations. Since the coefficient is 1, it makes it easier. In fact, the second one is probably going to be the easiest since it's positive, so I'm going to go ahead and solve for z there. I subtract the 2x to get it to the other side and add the 2y to get it to the other side. So z is equal to negative 2x plus 2y plus the 7. So now my z is by itself, and I know what z is. It's negative 2x plus 2y plus 7. So I can take that and substitute it for the z in the other two equations, and we would end up with a two-variable system. So that's what we're going to do next. I'm going to go ahead and plug it in for the z right here. So I get 4x plus 3y minus, and then this is where I'm replacing the z. So this z is going to go away, and this new part's going to be there. So negative 2x plus 2y plus 7 is equal to negative 1. The only thing I have changed in the entire equation is the z. I've replaced it with this portion right here. So now we distribute. And we combine our like terms. And then I'm going to bring this 7 to the other side so that the constants are together. So I add that 7, and we get 6x plus y is equal to 6. I now have a two-variable equation. Now I've got to do the same thing for the first one so that I could get rid of the z in that one as well. So I'll go ahead and draw a line here, and we get 4x plus 2y minus 5, and here comes my new z, negative 2x plus 2y plus 7 is equal to negative 21. So I've changed out the z in this equation, only the z. We distribute. I'm going to combine my like terms. That gives me 14x and negative 8y is equal to, I'm going to add that 35 to get it to the other side, and we get 14. So now we've got a two-variable system. And I'll go ahead and write them together here so that we have them one on top of the other like you've seen the systems there. All right, so we are ready to solve now with substitution or elimination. So again, I could get this y by itself and plug it in. In this case, it seems really easy to do elimination, so I'm going to do elimination. I'm going to multiply this bottom one times 8 because that's going to get my coefficients to be the same on y and have different signs, so when they add, they cancel out. So we multiply the entire equation. So we get 48x plus 8y, and don't forget to multiply it times that last one too. 8 times 6 gives us that 48. The other equation just comes over. We don't have to change it since it already had something that we can get the first one to be. Whoops, 14. Sorry. Now we're ready to add those two together. 48 and 14 give us 62x. 8y and negative 8y is 0, so that's going to go away. And 48 and 14 is 62. Last step, we divide by 62. X is equal to 1. Just like with the word problems, you can't stop there. We need the y and the z as well. So we can take this one and we can plug it into either one of these equations to find the x. So I'll go ahead, find the y. So I'm going to go ahead and plug it into the first one. I subtract that 6 and I get y is equal to 0. Now we have the second variable. To get the third one, I take both of these and I go back to my original equations and plug it into any one of these. I can also plug it into this one, which is already solved for z. So that's what I'm going to do there. So we get z is equal to, see that? All right, z is equal to negative 2 times my x value, which is 1, plus 2 times my y value, which is 0, plus 7. And so that gives me negative 2 plus 0 plus 7, which is 5. When you write the ordered pair for these that have 3 variables, you're going in alphabetical order. So x, y, and z. And there is our solution for this system.